Milks.
We are in some of the last videos that we're going to be making, and we're getting into some important concepts related to how molecules behave, not necessarily how just a bond behaves. So these concepts we're going to be covering in the next few videos start on page 28 and have to do with polarity and non-polarity of bonds and molecules.
Sure. When I hear the word polarity, the first thing I think of is north and south
Pole, which then I think of are opposites.
Right. Opposite what?
Of each other.
Right. Well, one's positive and one's negative.
Well, one's north and one's south. One's positive, one's negative. One's this side, one's that side.
Right.
Polarity has a lot of, the term polar just means two opposites.
Right.
And we're going to start to apply that to bonds and molecules.
Right. And we did bonds pretty good.
Uh-huh.
So we're going to look now how molecules that are simply bonded,
Like just two atoms.
just two atoms, but we're going to look at the molecule.
And how it could be polar or non-polar.
Right.
Because it's the simplest combination of two elements is a single bond. Here we go. Let's
Right.
see.
So nonpolar covalent molecules are what we call symmetrical.
They're like the same, they pass what I call the mirror test.
Yeah, the mirror test is a great way to do it. They are the same on both sides.
Horizontal, vertical, three-dimensional.
Right, so here
no
you
matter
go.
which way you look, it's at it.
Right, so if you look at this particular pure covalent nonpolar substance, it is the same on both sides.
Two of the same element, the electronegativity difference would be zero. So neither side's pulling electrons more than the other.
Right. Now that was the
Totally-
bond.
Totally even
That was
sharing.
the bond, so let's keep now to just the molecule.
Since this molecule is only two elements, the bond is what makes the molecule. And so therefore we can say symmetrical, not polar. Same on both sides.
Right. Now conversely, let's do polar.
Okay? Polar asymmetrical. So when we put a in front of something, it means not. That's a root word kind of thing. Different on one side. So it fails the mirror test.
Right. If we were to cut this molecule in half,
Horizontally. Like
Horizontal.
From left to right.
from left to right.
They're different sides.
Should I do that real quick?
Sure. Write it down.
Well, here, let's do it. Let's do
Show them how
it.
it would pass one mirror
Well,
test.
yeah, so if I cut it this way,
Passes the mirror test.
past the mirror test, the top and the bottom are the same.
But that's only one half of the mirror test. The other half of the mirror test is to cut it the other way too.
So if I cut it that way,
Fails the mirror
right,
test.
it's not the same on both sides.
So that's when I say pass or fail the mirror test, I'm taking this molecule and I'm chopping it up in three dimensions in my mind and deciding, okay, is there a different side? Is one side different? Yes or no? And if the answer is yes, I know it's polar. And if the answer is no, all the sides are the same, I know it's nonpolar.
And that's going to have some long-lasting effects on us.
Absolutely.
So, wrap it all up. Polar covalent is asymmetrical.
Different on one side. This is the simplest molecules, just two elements connected covalently.
Yep.
This doesn't apply to ionic because ionics are just like positive and negative charges. Polarity applies only to covalent compounds. Right? Mr. Milks is kind of...
Well, I mean, it's got a plus sign and a minus sign, so they do tend to do that. The problem
Right.
is they end up disassociating and
We always
all
put
other
the two
things.
words covalent and polar together. Polar
Right.
covalent,
Right.
non-polar covalent. We wouldn't say polar ionic. We would just say ionic.
Right. It's almost assumed that it has this degree of polarity, but it acts a little funny.
Yeah, so there's polar covalent, asymmetrical, like Mr. Milk said. Difference on one side.
Right.
Fails the mirror test.
And then there's nonpolar covalent, which is symmetrical or same on all the sides.
And it would pass the mirror test.
Right. Each side of the mirror would look the same.
No matter which ways you look at this molecule, it always is kind of the same.
Right. So next notes, we're going to combine a few more bonds.
More than one bond. So more than
Right.
two atoms connected, maybe 3, 4, 5.
Right. And now we got to look at the whole thing now and see how the whole thing polar or not. We'll get a little bit more
So we're going to
complex.
take those individual bonds and look at geometry and directionality in the
Yeah.
mirror test and see
Yeah,
if
mirror
we get
test is really
molecules,
what's
more
gonna be.
complex molecules are polar or not polar.
There you go.
Thanks, guys.
Intro to the mirror test.
Yep.